materials harnessing the potential of GGBFS.
Sir, sorry for disturbance.
Yes, sir.
Please keep it in full screen, sir. Slide so you can keep it, you can proceed. Slide so.
Now it's in full screen mode, sir. Can I check that, sir?
No, sir. No. Sir, again you rejoin now. Once you stop the sharing screen and again you share the screen.
Okay, sir.
Then it will get your voice and all clear. Even the screen also visible.
I'll go with the entire screen. That will be better. Now it's clear, sir?
Sir, yes, sir. Now it is fine. Please proceed.
Oh, okay. Thank you, sir. So my today's topic is on sustainable building materials harnessing the potential of GGBS. So you have attending this faculty development program from Monday. You might have hearing these things again and again. So I just want to know, ask few questions. What is meant by sustainable practice? Did anyone can unmute themselves or answer about what is meant by sustainable practice? Just to know about the background of the faculties. Sir, is it available for everyone? Anyone can unmute themselves or they can only chat?
Sir, they can only able to chat, sir. Why? Because we didn't given the rights to all the participants to unmute and speak. Whatever you are asking, they are giving in the chat box, sir.
Okay, sir. Then I'll share the link at the end so that we can have the quiz at the end of the session, sir. Okay, then I'll proceed. It's kind of referring to refers to the method and technique used in buildings design, construction, and operation that minimize the environmental impact, conserve resources, and promote eco-friendly development. That is very important. We need to conserve resources which is already existing in the natural resources. It can only be considered as a sustainable throughout the entire life cycle of the projects. So in sustainable construction methods, we have fewer things as in favor. That is, we have environmental benefits, which reduces the carbon emission, footprints, conserve natural resources, and promote energy efficiency. And next major important thing is that cost saving. Long term, we can save energy on water and maintenance cost. If you take example, recently I have went to Pollachi Municipal Corporations. In that, all the water pipeline systems they have kept for pumping systems rather than going for the gravitation systems. Before it might have they have designed before 15 years. So they have not planned for the gravity systems. They are paying a huge amount for pumping the waters. More than a maintenance, they are paying huge electrical costs. When I met executive engineer, they were saving about like they are not planned in executions. Actually, in Pollachi, if you look, there are many ups and downs. If you just keep on pumping water from the lower level to higher level, it will cost more energy, like we are consuming more electricity than the maintenance. So due to that pressure pump, there are lots of pipe leakages, burst, which is happening all around. So there is a stoppage for 3 to 5 days. So there is a huge loss in cost, which is happening if we are not planned for the long terms. Then we can improve indoor air quality, enhances occupant health and productivity. Then we can increase the property value. Sustainable building commands higher properties. Then we can compliance with the regular standards. As per the standards and the government norms, we can incorporate and construct sustainable construction methods. These are the favor things when it comes to the construction methods. These are the things which is against the sustainable construction process. First one is that higher upfront cost. there will be like initial investment in sustainable materials and technologies needs huge investments, because whatever we follow as a traditional method is like taking the raw materials from the natural resources and doing. If you go for the sustainable building materials, we should be investing huge material for material raw material productions and renewable energies. Next is limited availability, scarce availability of sustainable materials and skilled labors. This is one of the major drawback to find out the skilled labor for the upscaling of our sustainable building materials. Then complexity requires specialized knowledge and expertise. Even if you want to recycle the coarse aggregate from the concrete, it requires lot of specialized knowledges to incorporate those at least for the 10% replacements, which is good, which is not good, which method we need to follow. That requires knowledge and expertise in such fields to apply those categories. Then traits of potential compromise on aesthetics, functionality, or comfort. Sometimes it may be we need to compromise aesthetics or little bit of our comfort. Then lack of standardizations, inconsistent standards and certifications. Why? Because there is not much code books is available for the standardization of recent sustainable building materials and for the durability using the recycled materials. So if you look at the graph which I have showed here, this is the carbon dioxide emission on the Earth's surface between 1880 to 2019. The blue one indicates that is below zero. Red one indicates there is an increase in temperature due to the carbon emissions. If you just look into the y-axis, minus 0.6, 0, 0.6, 1.2. After 1980, the era of industrial revolutions, there is a constant increase in the carbon dioxide concentration. It has almost reached to 400 ppm, due to which there is a rise in temperature for 1.1 degrees Celsius globally. These are some of the innovations and future directions which we are recently looking for: net zero energy buildings, circular economy approaches, biophilic designs, advanced materials and technologies, smart buildings and IoT integrations. This fifth one, smart building IoT integrations, is the recent ones which we started to implement in civil engineering also, like using drones or sensors for health monitoring, etc. So sooner or India will have 1 lakh green buildings. That was published in the article, which you can see here. Uh, so there is based on this, Indian specific initiative have organized Indian Green Building Council, IGBC, Indian Energy Conservation Building Code, ECBC, and Sustainable Habit Mission. Then green rating for integrated habit assessment. So what is mean by green buildings? It refers to a structure that is environmentally responsible and resource efficient. That is very important. It has to be both environmentally responsible and resource efficient. Green buildings are designed to reduce the overall impact of the building environment on human health. It should not be hazardous material, by efficiently using energy and water, protecting the occupants' health, and improving productivity, reducing pollutions. Usually, you might have heard that in Delhi, if the pollution, air pollution gets worst, they will issue a notice to the construction or the builders to stop the construction of a building for about 1 week or until further notice. This is due to this one of the remedy actions which taken by the Delhi government to reduce the pollutions by stopping the construction practice. So you can imagine how much pollution that is caused by the construction industry itself. Green building especially uses sustainable materials in the constructions like recycled materials that are made from renewable sources. So we can save a lot of energy, like what I was said, a lot of electricity, even for pumping. If you go for the gravity methods from the tank to the residential areas, there won't be no issues, no requirement of power if needed. But if you go for the pumping system, there will be constant pressure in the water pipes. We need to constant electricity to such things. So these are the some of the articles which came in the newspapers. India is almost looking for affordable housing and to reduce carbon footprint and energy efficiency buildings through such government schemes. And green building is the necessity and not an option, says expert. So we are moving towards sustainability through green building concepts. And you can see the article that now PWT to use slag in building roads. Slag, which I have mentioned in the title, that ground granulated blast furnace slag. We can use that product as a natural sand or as well as the cement replacement methods too. Based on this Sustainable Development Goals, SDGC, even government is moving towards such initiatives. Even if you look at this poster, there was a startup challenge which was announced by the Tamil Nadu government uh, for one of the green building initiative. They have called for the competitions for what is the alternate solution for the M sand, which they are looking for the cheaper one too, so that you can win a prize of worth 7 lakhs too. So India is started to move towards greener, as you have seen already in the news articles. So now coming back, what is the sustainability? How it started. In early properties, we used to have local materials and passive design strategies. Like we used to build our homes with lime. In Rome, if you take, they used to build their homes with ashes, Valgunov ashes. Now we like same like we are started to use like fly ash and GGBS. In modern era, post 1970s, oil crash led to increased interest in energy efficiency. Then green building standards came like LEED, Leadership in Energy and Environmental Designs, and building research establishment environmental assessment methods to evaluate the ranking for the green buildings. This is the link which I have came through. Will be good. I'll just play it. You can watch it. It will be a 5 minutes so that you can understand better further.
Excuse me, sir. Sir,
Yes, ma'am.
the audio for the video is not.
Audio?
The audio. We are unable to hear the audio, sir.
Ma'am, that's why, like, everything is coming in the, they have written it. So you can,
Okay,
the
sir.
same thing they are, okay,
Okay,
2 minutes, ma'am. So you might have seen how it was developed. It was started, we all know it was started in 1980 by UNO government, but it was started in 1700s. They started by doing deforestation, of cutting more trees for making as a fuel for burning coals. So these are the environmental impacts of traditional conventional construction methods. During traditional construction, we harm the environment by depleting the resource, like which we have seen. There are a lot of trees has been cut down to burn as a fuel, and then it causes pollution and destroying the habitats which is living in the forest. It uses a lot of energy, produces waste, and emits greenhouse gases. And the toxic chemical and poor waste management contaminates both soil and water. If we just take Tamil Nadu, there are many tannery industries which is running, uh, dyeing industries also which is running, which is causing the polluting river nearby, due to which the river which is running due course around 100 to 200 kilometers. Whoever is living nearby, who is depending on that water, is getting affected with many type of disease, deadly disease, even cancers, skin cancers, some other cancers also, which is happening. These are the things which are causing due to the soil and water pollutions. Alternatively, there is a climate change also which is happening. Biodiversity loss, highlighting need for sustainable practices. These are the things which we usually do. Due to the which, if you just look into here, uh, due to this output pollutants, there's a change in climate change, acidification, eutrophication, ozone depletion, human health damage due to landfill and incinerations, then other environmental impacts which is happening. So that's why we are looking into the green building materials. Uh, that is perfect alternative to traditional concrete materials. So what is the thing is that we need to optimize the material usages, which is equivalent to of the standard dimensions, and we need to minimize the wastages through this waste management hierarchy. Using prefabricated components like precast structures, we can minimize the lot of waste as it is manufactured within the industries. And we need to plan reusages with, by future deconstruction mind to facilitate the reuse of materials. Like in the morning session, the sir was saying about prefab structures that you can reuse anytime, not like concrete structures. We need to demolish, dismantle. Uh, like there is a huge loss in materials as well as the money. Whereas in prefab structures, we can go for modifications or extensions, or you can replace the structures to some other places. These are the certification and standard for sustainable buildings, which is currently available all over the world. You can get the rankings for a green building concept or sustainable building concepts based on the energy consumption, carbon emissions. They'll be giving you the ranking systems, especially in India or in foreign. LED leadership in energy and environmental designs has been recognized as a green building council to certify in three different categories like silver, gold, platinum under each category: energy, sustainable sites, water efficiency, materials indoor quality, and design innovations. In those sustainable construction practice, life cycle assessment of the building is very important. Rather than we are talking about sustainable building practice and other such things, we are not calculating the life cycle assessment of buildings. Like many, I have heard many saying that this metal is going waste, so I am incorporating those things into the concrete. So they are ultimately saying it's a green concrete, as they have used waste into the concrete. It's not like that. Uh, we need to assess life cycle of the building. Like example, for a 50 to 100 years, central building will be considered as for a 100 years lifetime. For a residential building will be considered for a 50 years of lifetime. If you use plastics or waste materials into the concrete, it will ultimately deteriorate the whole structure without any research or things. If you uh, use it in the materials, like if you just replace fly ash without any research and development, if you just started to use in the concrete, it will give you the adverse effects than the benefits. So before going into the usage of any waste material into the concrete, you should be doing the life cycle assessment of that particular building materials. That is very important. There are some other standards for sustainable building measurements. The international standard for environmental management systems developed by International Organization for Standardization and certifications by involved in constructions. Their focus is to reduce environmental impact and improving environmental performance through systematic management. These are some of the buildings which is constructed around the world or as a sustainable construction projects. The Edge, which is located in Netherlands, it is known for cutting-edge sustainable features and smart technologies. It uses energy efficiency techniques by combination of solar panels and energy efficiency systems to achieve high level of energy performance. In India also, we started to use solar panels to install such solar panels. Also, central governments started to give many plans and schemes to conserve energy. And the smart technology they have implemented, integrated smart technology optimizes lighting, heating, and cooling based on occupancy and environmental conditions. They uses green roof to enhance environmental performance. Then another, the one Central Park, the building which is located in Sydney, Australia, it features green walls. The towers uses large vertical garden designs. If you look at this, you'll know it was designed by architect Patrick, contributing to improved air quality and aesthetics. Due to the hanging gardens in the wall, they'll be getting the fresh air. Then sustainable designs through energy efficient systems, water recycling, and sustainable materials. Even for flushing out toilets, we are using a huge amount of water is getting drained. Even the fresh water is getting drained. For that, we can go for the recycled waters which they have adapted in one central park buildings. And for community integrations, development includes public green spaces and amenities to enhance community interactions. In this, the Green Star has been given by the Adkin systems to showcase the integration of green infrastructure in high density urban environments. Now, we'll come back to the materials which I have mentioned in the title further, uh, which I have used for my research also. GGBFS, ground granulated blast furnace slag. It was produced during the process of iron ore. This is one of the byproduct. It uses iron ore, coke, which decomposes at 850 degrees Celsius. Carbon dioxide reacts with coke.
So excuse me, sir.
Ma'am,
The screen is not visible, sir.
from when, ma'am? Is it currently not visible or previously?
Just now, sir, it has stopped here.
Okay.
Now it is visible, sir.
Okay, ma'am. Okay, thank you, thank you. Whenever it went off, just inform me, ma'am. Then I'm done.
Okay, sir.
Thank you. Uh, at 850 degrees Celsius, at 850 degrees Celsius, limestone is decomposed to start to form slag. At 1500 degrees Celsius, due to hot air blast, there is a formation of molten slag, which start to float as a waste from the molten iron. During the process, uh, this is the manufacturing process of GGBS. It's a kind of byproduct while producing a iron. From further grinding from the blast furnace slag, if you just start to grind, you'll be getting GGBS, ground granulated blast slag. If you just grind it further, you'll get blast furnace slag. So these are the chemical composition of GGBS slag, which slightly varies and depends on the composition of raw materials in the iron production process. Like if you're going for the Tata steel plant, the calcium oxide may vary, silica may vary. If you go for the JSW, the percentage of chemical composition it vary. For that, there is a provision of code book which I'll show you. This is the code book number IS 16714 2018. This is the general requirement given by IS codes in table 1. Chemical requirement of GGBS, like in one manganese oxide MnO, maximum should be 5.5 by mass. Then test method is IS 4032. Then magnesium oxide, it has to be 17% by mass. Then loss of ignitions, it has to be 3. Then fluoride content, which causes corrosion in the steel, that has to be less than 0.1. Then insoluble residue 3. These are the methods or the percentage which is required chemical requirement for GGBs. Like I have said before, we can't replace just like that as it is one of the byproduct or the waste product which is generally available in the society. We should be thoroughly research and we need to check whether it will work without affecting the durability of the concrete or not. If you are just replacing with aggregate without washing, it will substitute to alkane aggregate reactions, due to which there won't be bonding between the concrete and the aggregate. And we need to test as per the standards as per IS 4032. Then if you just come beside for table 2, physical requirement of GGBS, which is mentioned in IS 16714/2018. Finest minimum should be 320 meter square per kg. Then slag activity index. Most of the people who are using fly ash or pozzolan, any other material, silica, missed to test. Do this only, you'll know how much your slag is reactive. If you take 7 days, it should not be less than 60% of the control OPC. Like if you say some OPC 43 is getting some strength, it should not be less than 60% of that. Then for 28 days, it should not be less than 75% of the controlled OPC creates limit of the motor tube. These are the conditions it has to be satisfied before going for sustainable building materials. If it is satisfied, you can directly use it as a, or you can declare that it as a sustainable building materials, or else there is a big no. In this stage itself, you can stop the work and you can look for the other alternative materials which can replace effectively. Most of the in the meetings or conferences, people used to say I'm replacing these things, but if you look at the background of the study which they have carried out, they might have missed these codal provisions, basic requirements which has not satisfied. If we just looking further in the notes, for the purpose of testing of GGBS as per IS 4031 Part 2, wherever reference to cement has been made, it may be read as GGBS. Slag activity blend of 50% GGBS and 50% control OPC conforming to IS 269 and not less than 0.6%, not more than 0.9%. This has to be satisfied for the slag activity index test. So if you just this is the global OPC manufacturers 2018 and predicted in 2030. Blue one is the one which is already happening and recorded in 2018. 2030 is the forecasted one. If you just look into that 2030, India will be going to increase its production capacity to is double the time. So almost all the countries like USA, Indonesia, everything is like they are planning to increase its production capacity. So ultimately, carbon dioxide emission also will be double of that. To reduce that cement productions or energy consumption for the production of cement, everyone started to look which will save in energy consumption. Then Port of GGBS. One is Ca2A2 SiO7. Second one is Ca3Mg SiO4. GGBS contains latent. It doesn't react immediately with water like pozzolan. However, in presence of calcium hydroxide produced from cement hydration, GGBS undergoes a pozzolanic reaction, fly ash. In the crystalline phase, calcium silicate and alumina react with calcium hydroxide to form hydrates. This is which will go through during the hydration process in the cement, contributing overall to the strength and durability of the concrete. Fine-grained GG-based particle improve its density and rate is very important. While GGBS itself a low speed of hydration, its contribution to the overall heat generation of concrete is significantly lower than that of Portland cement. If you just look into the picture, the left one shows the Portland cement. Interaction between these two aggregates is very less. There will be chance of porosity, thereby there will be reduction in durability because there is a resistance to sulfate attack, chloride attack will be very less. It will be, but if you look alternative, if you look into the GGBS, the interaction between the aggregate and the cement paste is very high in the hydration process due to the precipitation of calcium silicate or calcium aluminate. This is, happens to be the pozzolanic reaction, CS gel formation. That I'll send images in the further slides. Due to the improved hydration reactions, the formation happens in the concrete. If you just look into the normal concrete left side, there will be porosity. If the porosity is connected, there will be points of water can penetrate between or air can penetrate. If it is RCC, there is a chance for the durability constraint because it start to corrode due to the penetration of air and the water. And if you look into the picture concrete with the GGBS, it's like there are closely packed ITZ, interaxial transition zone, because of the hydration product which formed during the hydration process. So it's a strong then month of carbon dioxide capture in fine aggregate GGBS. Mostly in GGBS, I have done research as a replacement for fine aggregate post aggregate to of cement. These are the heat rate of concrete with and without GGBS. If you just look into this, this is controlled concrete. Peak hydration process mix water. Then this is 20%, this is 40%, this is 60%, this is 80%. If you just replace it to the maximum, there will be a huge reduction in the, this is around 0.5, this is around 2.5. So due to this, the reaction, pozzolanic reactions will be less, shrinkage, shrinkage cracks will be less. In longer run, like what I said before, life cycle assessment, in the long run, better solutions to compared to other things. Then curing age, normalized heat wave flow. If you just look into this also, GGBS with curing results, heat flow is very less compared to the normal. Just look into the images. There is a formation of ettringite and CSH, calcium silicate hydrate. You can see through the images. In the next picture, I'll show you clearly that the left one, if we normal, that is like if you take M21 is to 1.5 is to 3, fine aggregate, 3 part is coarse aggregate. Along with this is GGBS incorporated concrete. You can see the formation of ettringite. You can clearly see the formation of CSH. There is a close bonding between the paste and the aggregate it forms during the hydration process. In the long run, it poses we can reduce the land filling as well as the concrete productions materials too. Test left one is the one of the GGBS. You can check almost it exhibits the same chemical composition which is present in the GGBS, which I have used for the research works. If you just look into that Ca, magnesium, silica, almost it is equivalent to similar physical and chemical properties, then you can go for the replacements, or else you need to check for the codal provision standards for the replacement, or else it will give you the process. So India is fast developing countries. It consumes a large amount of cement for the infrastructure development. Concrete is the second largest consumed product. Can anyone guess which is the first consumed project, consumed materials other than concrete? Is that water is the first one we are consuming a lot. Second, we are consuming a large amount of cement, due to which we are producing a 1.35 billion tons of carbon dioxide annually. So, which I have shown in the first graph that due to the carbon emissions, we are currently producing 400 ppm, which is about to 1.2 degrees Celsius rise in the temperatures, due to which Antarctica started to melt and every adverse thing started to happen. For that purpose, we are moving towards sustainable built environment. Ground blast furnace slag is proposed as an alternative material to reduce cement usage and associated cost. We can replace directly, and associated cost is the one during the productions, grinding, everything can be reduced ultimately. It has similar chemical properties to that of cement, can be used as a partial replacement for cement. Which we have seen, slag act as an excellent aggregate binder, improving corrosion resistance and reducing micropores. Even many cement companies now started to produce or the research on the water repellent concrete techniques, even denser than this. Many people have started to research on this so that it reveals a compact hydration structure in the mix. Like FESM, more than some, it gives you clarity image which you have seen. It confirms the development of nano GGBS in the leadership in energy and the environment designs recognized GGBFS in concrete as a sustainable practice. Using GGBS can learn LED points by improving project sustainability. It will give you the green rating, promotes sustainability, improving living conditions and resource management. Construction is crucial for progress impacting social and economical. What is the problem with the current existing cement? Why we are going need to replace with the sustainable building materials? Because you know it is the third largest emitter of CO2. Second one is the steel production unit, which will produce the more carbon dioxide. It accounts for 7 to 10% of the global CO2 emissions. It produced 284 kg of CO2 per ton of cement, and it's growing up every 5% per year. So due to this urbanization and industrial increasing recycling and waste management challenges, GGBS is beneficial for high quality cement mortar and cement productions. So these are the major advantage of using GGBS. It has high workability, reduces bleeding, then reduced permeability, chloride resistance, which is very important for RCC, so that there will be a chance of reduction in corrosion, which is happening in the concrete. Then improved sulfate resistance. You can go for the offshore structures or the structures which has handling more chemical resistance, like frost resistance, improved workability. We can go for the replacement of cement, and you can go for the mortar to enhance workability and durability, and for soil stabilization, improving soil properties in geotechnical applicants, and for the precast concrete, like more controlled environmental will be having in the precast yard, so that even if the hydration process is slow, you can achieve high strength concrete within 28 days in a controlled environment like precast concrete yards. Thereby, we can reduce the carbon footprint in around the world by using GGBS, and this is also one of the industrial byproduct from the steel industry. We can reduce the landfill and conserve the natural resources. If we just start to landfill, when once the rain comes, the chemical components whichever is there, sulfate, magnesium, fluoride, which will ingress into the soil, thereby start to deplete the natural resources. Like we can't do it for the agriculture, it will mix with the groundwater. There are many adverse things which will be happening if you dump the byproducts in the lands by doing landfillings. Then it will enhance the durability, heat of hydrations, reduce the heat of hydrations, beneficial mass concrete applications. There will be chance of thermal crackings like shrinkage in the mass concrete can be reduced using this kind of post-organic activity materials, improved workability and pumpability in the concretes. These are the values which I have showed through EDAX test. In cement, line is like 3.61. In GGBS, it's around 47.91. Silica 21.28. This is 31.35. Magnesium, aluminum, almost equal to that of this one. Loss of ignition, which I have seen in the code book like IS 16714, it said permit about 3%, but here you can see about 0.98 only. It's all within this permissible limit which is given by the code book. This is also one of the EDAX test results for AIS cement and GGBS. Then this is the ball mill grinding process for reducing the size of GGBS further. With so that the fineness will be reduced further. It's like filling a jar with gradation methods, so that you will be getting more compacted particle. This is fresh properties of concrete. This GB1, GB2 and all it mentions the mix type which have been added to the. Then coming back to the reinforcement details of the beam, which have been 2 8 number of dia and at the top and 2 10 number of dia at the bottom has been casted and tested with us different GG based different mixes using a loading frame, hydraulic jack of capacity 50 tons, loading frame of capacity 100 tons, and proving ring of 500 tons with 3 jack at the bottom. One is L by 2, L by 3, and L by 4 with simply supported support connections. And this is UPV test method results. The compressive strength. Then this is fire resistance test, which happened to be done for the control mix and the GG based mix. Almost exhibits the similar type of properties, but even after going to 900 degrees Celsius in the oven, it exhibits good strength capacity compared to control mix. And these are the tests which have been. It forms low deflection curves and absorbs more energy in the GG based beams. More number of structural cracks in control beams have been found out compared to nano GG base. As it the GG base, the metals is more bonding. It's not showing the micro cracks. After once it reaches from certain load, there's a huge difference between the first crack load between the control concrete and the normal concrete. And the crack width also wider, so that the deflection is also getting more compared with other concrete beams which mixed with the previous. So, like which you have seen in the previous things, now it's moving towards role of artificial intelligence in sustainable constructions. So the role of AI and ML in sustainable communities. So whatever the method which we are practicing traditionally and incorporating the sustainable building materials, nowadays in the civil industry itself, role of artificial intelligence and machine learning plays a very important role in measuring the wastages and helping in energy management, thermal comfort, power, cooling, circulation and automations. That all within the indoor environmental. And if you consider outdoor environmental, noise, air pollution, waste, real estate and prices, infrastructure development, life cycle assessment, and rain predictions. Even that's what I have told in the last talk also regarding the life cycle assessment and predictions using artificial intelligence and machine learning. This plays a huge impact in the civil structure, especially with the sensors. You go look into the structural health monitoring. The sensors plays a major role. Just like if you just insert the chip in the concrete or set something to monitor wherever you are in your office, you can monitor the health of the structure with this artificial and machine learning techniques. It will give you the signs or the warnings to the control unit beforehand. It will give you predictions. So this much is the life capacity of the structures it will withstand. Using this, many renovations are happening. Even we can improve the capacity of the building using artificial intelligence and machine learning. Even in the which I have attended some workshops in the Chennai, that they have talked about the Udaipur Palace. They have incorporated these techniques for finding out the stress distributions and the leakages in the building. They have improved the quality of the building to the maximum. Now they have opened for the public to visit using this artificial data science, or else it will be taking many years to solve these problems or to know the nature of the building conditions. So these are the things which I have taken just to inform you things about what are the things in the sustainable construction practice research is going on using AI techniques and machine learning techniques. In 2001, John Smith and other authors have discussed about the integration of AI-driven decision support systems in project management, emphasizing their role in facilitating sustainable construction practices. Challenges such as data quality, interdisciplinary collaboration, and regulatory compliance are examined. You can uh, input the data like code book. You can input the range, it has to be there in the deflection also. You can attach it in the beam itself. If it is exceeding, it will give you the indications. And by showcasing the capability of AI to address sustainability challenges, this paper underscores the potential of AI to revolutionary the construction industry and contribute to a more sustainable built environment. And in 2020, Energy and Buildings Journals, it was discussed that machine learning in improving the accuracy of energy simulations and forecasts, thereby enabling more informed decision making, design, and operations. Even in the water river area, which I mentioned, if someone is polluting the river, they can identify within which range it was polluted, so that they can localize the people who can done this. They can identify, and with the help of sensors, they can identify what is the level of pH, what is the chloride content, and other toxic contents which is present in the river, whether it is eligible to drink or not. What is about the pH value? Everything can be identified with the help of machine learning. Also, it's implement of machine learning in real-world projects, demonstrating significant improvements in energy efficiency and sustainability outcomes. In energy and efficiency, it's like uh, we can adapt to the environment. We can, based on the number of people, we can increase the power consumptions. If people is less, due to the adaptation, it can be switched off automatically. These things can be trained to the machine learning, and we can integrate within the building to save the energy in the buildings. This current research and identify future directions. This paper underscores the potential of machine learning to revolutionize the sustainable building designs and contribute to the broader goals of environmental sustainability. Next is like in 2001 Construction and Building Materials Journal, it was reviewed that AI techniques including machine learning algorithm, neural networks, and genetic algorithm that have been employed to predict material requirements, optimize design process, and manage construction waste. Key areas is to predict models of material demand, forecasting, AI-driven tools for optimizing structural designs, and use of AI in managing and decreasing construction waste. This also addresses the challenge of implementing AI technology in construction industries such as data quality, integration of AI with existing construction process, and need for skilled working sustainability, which I have discussed in the first slide as a disadvantage. It required skilled labor, and it required expertise in the field, even for the recycling. That is one of the major drawbacks which we are facing. We can't employ the expertise in everywhere to monitor such things. In that place, AI plays a major role. These are the links to my journal which I have published in the GGBS. One is in Q1 and another one is also Q1 from Buildings Engineering Journals. You can refer to it. And these are my references. Thank you. To ask you a few questions so that you can post yeah. Everyone got the link, I guess. If you just start to post the answers so that is it working? Everyone, yeah, it started to work. I can see the polls here. So far, 9 people have been voted. What is the vision of the Indian Green Building Council? First option is to maximize profit for the construction industry. Second, to enable a sustainable built environment for all. Third one, to promote energy efficiency in buildings. And last one, to minimize the environmental impact of buildings. I'm getting 13, 14 plus 4, 18, 22, 23 answers. I'm getting maximum answers to enable a sustainable built environment for all. Okay. Once it's crossed 50, we'll move to the next poll. Okay. So let me reveal the answers now, or let me wait for some more time. Okay, I'm getting answers to enable a sustainable built environment for all. Maximum. Okay, let me reveal the answers. Answer is all. We'll move to the next poll. What is the total footprint of project? Any guess? Okay, 7.5 billion square feet, 12 billion square feet. Many for 9.75 billion square feet. Okay. Okay. 12 billion square feet is getting high. 9.75 billion square feet. This is the total footprint of the project registered with IGBC. No one got answer for 5 billion. Okay. Good. Answers are coming up. Let me reveal the answer. Yes, 9.75 billion square feet is the right answer. I'm just moving with the second question. So where is the Indian Green Building Council located? Hyderabad, 15 people has been answered for Hyderabad. 18 Hyderabad. Chennai no answer. Mumbai no answers. Hyderabad is getting high. Okay, let me reveal the answers. Mumbai one came. Okay. Answer is Hyderabad. Thank you. Next. What does a green building aim to do in terms of its efforts on environment? First option is maximize bad. Second one, have no impact on the occupants. Third one, completely reduce any bad effects while maximizing any beneficial effects. Okay. Response to the completely reduce any bad effects while maximizing any beneficial effects. Okay. This have only three options. So competition is high. Let me reveal the answers. Yes, completely reduce any bad effects while maximizing any beneficial effects. Okay, thank you. Next, what is the primary focus of green throughout their life cycle? First option, maximizing profit for the construction industry. Second one, environmentally conscious practice. Third one, creating visually appealing structures. Fourth one, minimizing initial construction costs. First one is not getting answered. Maximizing profits for the construction industry. Okay. The answers? Yes. 29 people have been answered correctly. We'll go to the next one. We can type for this, I guess. Why is GGBS used in cement? Why is GGBS used? Okay, strength. I guess. Okay. Offers great durability, reducing likelihood of concrete resistance to damage from multi-silica reactions. Replacement of cement with 30% post-landing action resistant to damage from multi improve durability, strength, durability to reduce porosity and to increase strength. Okay. 16 reduce voids and increase strength, environmental low heat of hydration to reduce cement content, hence reduce carbon footprint. Good. Enhanced workability. Good. It long run strength increases. Okay. Okay. Good. Now we can start voting for this. You can vote for which will suit best for this. Yeah, one person voted. You can do the vote which is more right in terms of GGBS among the participants. among yourself so that I can get the result at the end, which is more relevant. Okay. 12, 13. We can see the results at the end. Okay, we'll reveal in 10, 9, 8, 7. Okay, we'll reveal. Yes, 25 people have been voted. Yes, popular one is the one. Ground granite blast furnace slag offers great durability, reducing the likelihood of concrete thermal cracking and improves fire resistance and damage from all case irrigation. It gets the maximum vote. And second one is the pozzolanic action, and third one is the which is better, fly ash or GGBFS. You can't the fly ash or GGBS. The question becomes different here. Okay, 13. I'm getting maximum GGBS and few fly ash. Can use both. Which is better? You can use. Okay. I'm getting maximum GGBS. Okay. 30. I have grasped space. I'm getting the answers. It's taking a bit of time. Can use both flash GBS, that is size, material type, durability. Thank you. Okay, we have reached at the end of the presentations. Thank you. Any queries? Thank you everyone for patiently listening to this lecture. Thank you everyone. Sir Lingeshwar, I have completed the talk.
Thank you, sir. Thank you, sir, for your enlightening session on sustainable building materials. The use of GGBS as a sustainable alternative in this construction has shed new light on how we can reduce our environmental footprint while maintaining the structural integrity. On behalf of everyone present here, once again, thank you, sir, for taking the time to share your knowledge and being a part of this faculty development program. Sir? As we conclude this week 1 week faculty development program, I want to express our heartfelt thanks for your commitment and enthusiasm. Your active participation has made this program a rich and rewarding experience. We hope the knowledge and connections you have gained will be valuable in your professional journey. Thank you once again for your dedication, and we wish you all the best for your future. And I request all the participants to please wait for 2 minutes. We'll send the feedback link. I would now like to invite our esteemed head of the department, Dr. P. Polraju sir, to share a few words on the success of the faculty development.
Please, 2 minutes.
Sir, you may continue now, sir.
Yeah, Dhoni, shall I continue?
Yes, sir.
Yeah, thank you very much for this opportunity. And I congratulate the all organizers and I congratulate the all participants for successful completion of this 6 days faculty development program on sustainable construction practices. And I think, as per my observation, being as the chair of the department, I think it has not happened ever, even in across the India, this kind of FDP. See, that is, of course, you have to give this comment, but in turn, I'm only giving the reverse comment this one. Why? Because my organizers, especially Dr. Lingeshwaran and Dr. J.D. Chaitanya, made this program grand success in terms of every day they are posting the attendance, how the all participants are attending. Maybe you are a teacher, or you are a scholar, or you are a MTech student, but that discipline is required. See, we have registered, but because of our unavoidable circumstances or unavoidable commitments, we were missing some sessions. But that should be noted, that should be recorded properly, that they made it very properly. Of course, even I also surprised the way they conducted the program. And every day I used to post the attendance status in the respective group, that SDB, FDP group. So it indicates that, even all participants may get the information that how many sessions I have been attended and how much attendance percentage I am having and how much possibility is there to get the certification. See, if we are not maintaining that, so there is a chance of misuse actually. So that was our intention. However, thank you one and all for all participants. All speakers, all my resource persons who rightly accepted our invitation and they shared their valuable knowledge, their ongoing researches and their ongoing works along with their scholars and along with their master students in the different organizations, starting from academic side, even industry side. So many speakers we could able to map for this FDP. But the main cooperation we got from participants only. So there was a very seriousness from the all participants. Even my organizers and my student organizers, they also done well. And we just given to them by giving the profiles of the speakers, and they have taken care and we taught them how to conduct this whole program. So this is only possible because of my all organizers, especially my faculty members. I just told them my plan, how to conduct this, and they made it grand success. I'm so happy for this. I don't think so. The program may happen like this, or happened as of now at any place of even if you talk about the categories of deemed universities or private sector point of view, I'm speaking. So I'm not generalizing the comment actually. I'm so happy. So that is why I'm speaking like this. The attendance giving in a one proper format everyday basis. So it will give the very good impression on the program actually. Who are going to acquire the attendance of up to 80 5%. How much? Yeah, around 253 participants have successfully completed their FDP with the percentage of 80 percentage out of 475 registered participants. See, remainings who are not having the prescribed or whatever we the percentage to get the certificate, digital certification, which we are going to send you very soon, maybe within 1 week actually, already under the process, so that we will share you in the groups or in your respective mails. However, the consolidated attendance list, speaker wise, on every session, my coordinator, Dr. Lingeshwar, and our convener is going to share with you all in this FDP. Thank you, one and all, once again. And recorded link, because you people were asking, keep on asking, sir, please try to share the PPTs which the speakers have been presented during the sessions. So that is, of course, we are trying our level best. What I wanted to say that some speakers actually they are very reluctant to provide their confidential documents actually. However, we have been successfully recorded all sessions. That records with that one link actually. So that link. Uh, okay, I'm going to post now in the chat box. I'm going to post now in the chat box, my dear participants.
I request all the participants to please wait for 5 minutes. We'll be sharing you the YouTube link for all the sessions.
Yeah, sorry for the interruption, my dear participants. I'm going to conclude now within a couple of minutes. And as I already mentioned, as per our assurance, we have already provided the link in the chat box. All recorded videos of the all 6 days, you can able to find that link, that YouTube channel link. So you can able to download if you really want it, and even you can get that knowledge if you when you are going to teach to your students. Even any scholars are there for their research purpose. Even for any MTech students are there for their master's dissertation purpose. You can utilize this so-called knowledge which is shared throughout all 6 days actually. So once again, I thank you all faculty members who joined for this FDP and who made grand success. Once again, I thank my organizers. Especially, I would like to mention their names because maybe to complete or to do this kind of whole program, maybe it may be online. 10 people have to work, but only 2 people worked, and majorly on one hand, actually, Engager could able to run this program. Actually, I'm most thankful to him. Of course, he is my colleague. I thank you all once again. Anything else, Dhoni?
No, sir, that's it, sir. Thank you, sir.
Yeah, thank you very much.
I request all the participants to fill the feedback form. It's given in the chat box.